Okay, I thought about doing like a beginners oriented overclocking tutorial video for the ASUS Sabertooth Z77 motherboard and for the Intel Ivy Bridge and Sandy Bridge based CPUs. So I suddenly got these parts as a loan from another local user. So thanks to Alexi for lending me the parts. I used these specific components for some other testing purpose, but I really thought about doing like a short tutorial, and I wanted to see like how well this particular 3770K actually overclocks. Now many of you might be asking that why am I doing like an Ivy Bridge overclocking video or a tutorial video in 2020, as these parts originally came out to the market in the spring of 2012, like over 8 years ago. Well, these parts still have quite a lot of relevance for many people who, especially for those who live in the more like developing countries where people don't have like too much money to spend on a computer. These parts are still like a great alternative value-wise to modern new stuff from the actual stores. So you can get like a 3770K CPU for maybe like between 80 to 130 euros in the second-hand market, and a reasonable Z77 motherboard like the Sabertooth used in this case maybe between 60 to 150 euros, and memory you can get really cheap DDR3 memories, really like 2 times 4 gigabytes can easily go for just a few dozen euros or so. And even 2 times 8 isn't that expensive really. So in this particular case I'm running a 3770K CPU. It is not deleted. Deleting stands for removing the standard integrated heat spreader from the CPU itself, replacing the thermal interface material, or so-called thermal grease or thermal paste, between the actual CPU die and the heat spreader, or the so-called IHS. So you can get a lot better temperatures with something like liquid metal compared to the standard thermal paste Intel uses. So this is like a 3770K, like if it was bought new from a store. The Sabertooth Z77 motherboard represents like a bit above average in terms of quality when it comes to Ivy Bridge or Sandy Bridge based motherboards. It is not the best one for overclocking, but it's not the worst either. So I would call this like a slightly above average or so, or maybe in like the average category. The very high-end boards like the Maximus series boards, they are better for overclocking purposes than something like this. And when it comes to the memory, I'm using 2 times 4 gigabytes of G.Skill Trident X, 2600 megahertz with 10, 12, 12, 31 command rate 2 timings, and they feature Samsung D-Die based DDR3 memory ICs, so they are very good for daily use and overclocking. In this particular screen view you can see total memory 8 gigabytes and DDR3 1600. Memory is not set to the aimed target values after you clear a CMOS or you boot the computer for the first time. So the standard values that are labeled on top of the memory itself, they are like an overclocking profile. So this 1600 speed is like the JEDEC standard of DDR3, although it varies a little bit. The real JEDEC standard or default speed of DDR3 is 1333, but some kits will refer to 1600 or even as low as 1066. And we have one SSD installed, and that's pretty much it. BIOS version is 2104. There might be a newer one available out there, but this one is from like summer of 2013, so it should be like relatively new. So we can enter the BIOS by pressing F1 on our keyboard. And once we press F1, we will see this modern like UEFI graphical interface layout, but it's much easier to overclock the system in a more like standard overview. So we can go to the advanced mode by clicking over here or pressing F7 on our keyboard. So I will do that now, and OK. So this is like the more standard BIOS or UEFI layout you have generally seen. So the first tab is the main tab, and it tells us the most basic information about our system. So BIOS version 2104, it's dated August of 2013, CPU 3770K at stock speed of 3.5 GHz, total memory 8 GB as I already said. The real overclocking happens on the AI tweaker tab, so we can go there by pressing right arrow key on our keyboard. So at the moment we have this safe mode target speeds above at the moment. So 3.9 is the stock turbo of 3770K, and target DRAM speed is 1600 MHz. And by the way, I'm running a custom water cooling loop on the CPU, but if you are getting these parts for daily use nowadays in 2020, I would assume you will be using something like a simple air cooler or a used or a very cheap AIO. Custom water cooling loop is very expensive for parts like this, especially if bought new. So AI overclock tuner you want to set to either XMP or manual. XMP will load the overclocking profile of your memories automatically, so it would set 1.65 volts on the memory. It would set the DRAM frequency to 2600 MHz of this particular kit, and it would set only the main timings of the memory, so 10, 12, 12, 31 and command rate 2. Subtimings will be auto. What I like to do is that I like to set this to manual, and I will set those same settings myself. So you can do it. You can do it this way as well. So it will work just fine. So manual base clock you want to keep at 100. It's easiest to overclock everything when base clock is left at 100 MHz, and then you can be pretty certain that nothing gets messed up pretty much. Turbo ratio, we want to set this to manual, and I like to do like all core overclocking, especially for starters. It's much easier to do than per core overclocking, especially if you are a starter. It's much easier to overclock and stress test all cores at the same time. So we want to achieve an overclock of 4.5 GHz. That is generally easy to achieve, at least on the Ivy Bridge based CPUs. Normal Sandy Bridge like 2600K, 2500K, 2700K, they are actually capable of running even higher clock speeds, at least on air or water cooling, because they are soldered. Ivy Bridge CPUs like the 3570K, 3770K, they have relatively bad thermal paste between the core and the IHS. But we want to try an overclock of 4.5 GHz. So now it would set synchronizing target CPU turbo speed to 4500 MHz. Internal PLL over voltage, I usually like to set this to enabled, but I'm not fully sure if it really matters at all, at least on air or water cooling. CPU bus speed to DRAM speed ratio, I recommend you leave this at auto to have the maximum amount of multipliers available. Memory frequency, you have to set this to the speed that corresponds with your installed memory. If you have some very basic memory, then you might want to set like 1600 MHz, but it really depends on the memory you have bought and what you have installed in the system. So just look at the sticks themselves. 1600 is very common, 1866 is very common, 2133 is also very common, but once you go to like 2400 and above, it starts to get very rare. But I will set 2600 MHz, which is the like standard overclock of this memory kit, or the XMP frequency. Then we don't want to use OC tuner, because that is like an automatic overclocking feature on this board. we want to go to the DRAM timing control, and I will set the main timings to the same values that I mentioned on the big white label sticker on the memory sticks heatsinks. So 10, 12, 12, 31, and the standard command rate is actually 2, but generally with most of the kits out there you can actually even run command rate 1, and command rate 1 has better performance than command rate 2. So you can try to set the command rate to 1. I will leave most of the sub timings at auto because that's really like fine-tuning territory. You really have to spend a lot of time if you want to max them out. So it's easiest to just set the main timings and leave rest at auto pretty much. Then we go to CPU power management. Now the thing you want to do when it comes to CPU overclocking, you want to have enough headroom power wise, but you don't want to run to the temperature limit of the CPU. So I will, just to be sure that I will know that the CPU will not throttle because of higher power consumption, I will actually max these settings out. So long duration power limit 255 is the max, and maximum time frame 32, not sure, it should be in seconds, so 32 seconds, and I think this is in watts, so 255 watts is the max setting we can use over here. Same thing over here, so max setting over here, and primary plane current limit, so this is 1/8 of an amp. So the maximum setting is 1024 divided by 8 amps. So I'm not like fully sure how much that is, like maybe 150 amps or something like that. So I will do the same thing. So all of the settings here will be actually maxed out. I do the same thing on all of the platforms pretty much. So we still have the temperature limit on the CPU. So if the CPU temperature goes too high, it will throttle the CPU speed and voltage down, but we don't want like power limitations to throttle the CPU. And that could happen even if the CPU is very, very cool, if we have very strong cooling solution. Now we go to the Digi Plus power control. This is a very important part in the BIOS. So CPU load line calibration you really have to set yourself. When you set some specific V-core value to the CPU, you want to maintain that at the set value under load. So if you set, let's say, 1.3 volts on the CPU, you don't want the V-core to drop down when the CPU goes under load. So if we don't use any load line calibration, if we set 1.3 volts on the CPU, that voltage value could drop to like as low as 1.2 volts under load. We might not want to have that high voltage running all the time at idle, but we want to have that 1.3 volts set value at least under load. And what I found out is that the best value on this specific motherboard is ultra high when it comes to load line calibration. When I set V-core at 1.25, if I used the value of high over here, it would drop the V-core to 1.225 under load, and ultra high gives like static value. So 1.25 idle, 1.25 under load, and extreme will overshoot a little bit. Now voltage frequency, this is like a fine-tune setting, so you might be able to squeeze a few more megahertz stability wise if you increase the switching frequency of your power delivery system. Stock frequency is 300 kilohertz, and we can go up to 500 kilohertz over here. So increasing the setting should, at least in theory, improve your stability, but it will just result in slightly warmer temperatures on the VRM. But the difference between 300 and 500 kilohertz is so minimal that it should not matter really. So it's pretty much safe to set 500 over here. Power phase control, I recommend you use either optimized or extreme. Optimized should be very, very good. T probe is thermal balance, so that's what I would use in the power duty control. Current capability is kind of same thing like those power consumption settings we just changed. So you can use the max value it already set by itself over here. So it's just like current capability option, so it doesn't really matter. So you can safely use 140%. Don't get scared about the red color over here. CPU power response control, well, ultra fast should be the best option over here. So yeah, apply a higher value for extreme overclocking. So you can try ultra fast, the maximum setting over here if you want to. DRAM current capability, you can use the max values again, because memory sticks themselves, they generally consume very little power overall. So it's not dangerous to set this to max value over here. Voltage frequency we will set to max as well. And power phase control we can actually use extreme, because it doesn't really draw that much power. That's pretty much it. Then we go to CPU voltage, and I like to use manual, at least for the primary testing. Once you have found out some stable settings you want to use, then you can try to play with the offset option. But for initial testing, I recommend you use the manual mode. And I will set VCO value to 1.25. If you use like a strong cooling solution, like a very large like air cooling tower, like Noctua NHG14, D15 and so on, or some kind of an AIO, 1.25 should be like a safe value to use. But don't start with any higher value than this, because the temperatures do go up very quickly on an Ivy Bridge CPU that is not deleted. So just saying. So 1.25 is completely safe 24/7 if you can keep the temperatures down, even if it has red color over here in the bars. DRAM we want to set to the value that's mentioned on the top of the memory sticks themselves, so on the big white sticker, so 1.65. VCCSA is the voltage of the memory controller inside the CPU, so you have to increase this if you run high memories. Higher value is not always better, so I actually found out that 1.15 is very good on this particular CPU. When I tried to set 1.25, it actually didn't want to post that easily. So higher is not always better, you have to test it out yourself. But even 1.25 is safe on this value for 24/7. But don't go very high, just straight out, like straight from the get-go, like 1.4 or even above. So I will set 1.15. CPU PLL, just set it something that's very close to the stock value of 1.8 volts, like 1.7 or 1.8. PCH is the voltage of the Southbridge chipset, or the chipset, so the Z77 chipset. You can just leave it at auto. And I recommend you disable CPU spread spectrum. And that's pretty much the settings. So 4.5 GHz overclock on the CPU, 2600 MEMS. So this is kind of good combination when it comes to an old Ivy Bridge setup. And then we can go to the if you don't have any fan connected to the CPU fan header on your motherboard, you have to set the CPU fan speed thing from monitored to ignored. If you don't set it to ignored and you don't have a fan plugged in, you cannot bypass the BIOS welcome screen. So you have to ignore this if you don't have a fan plugged in, if you want to get to the operating system. And that's pretty much it. We can now, and then you can obviously save these settings in the ASUS OC profile section. So just name it like daily and save it to one of the memory profile spots inside the BIOS. And that's pretty much it. We can just double check, and then we can F10 and save and exit. Okay, so once you actually get into the Windows operating system, the programs I would recommend you to install are CPU ID, CPU Z to read all the basic information about your system like CPU, memory and mainboard. So when we open CPU Z, we can see Intel Core i7 3770K running at a core voltage of 1.25 volts, which we actually set. 4.5 GHz on the CPU across all of the 4 cores. 4 cores and hyperthreading are enabled, so 8 threads. Motherboard is ASUS Sabertooth Z77 2104 BIOS, and memory we can see 1300 MHz. So DDR, so DDR3, DDR2, DDR4. DDR stands for double data rate. So 1300 MHz times 2 equals 2600 MHz. So 1300 MHz memory frequency is DDR3 2600 MHz, and with 10, 12, 12, 31 command rate 1 timings, and SPD G-Skill Trident X 2600 Cas10. Now you want to have some temperature measurement program. I usually like to use Core Temp, but with Core Temp you cannot really measure at least the VRM temperatures of the motherboard, and you do want to keep an eye on the VRM temperatures. So I would recommend you install something like hardware monitor, hardware info, if you want to read those temperature values. Usually VRM temperatures aren't an issue if you have adequate airflow around the CPU socket and just adequate airflow inside the whole computer case overall. So at the moment we are running like low 30s on the CPU core temperatures. For initial testing you can use something like Cinebench R15. It's like a good indication of stability, but it's not hard enough to call anything like daily stable. So now we can start this test and look at the vCore value. Does it change from the idle value? So when the CPU goes on the load, fans kicked in, but the vCore value actually remains the same. If I used a low light calibration of high, it would drop down to 1.225, so like 25 millivolts. CPU core temperatures are like mid 60s, so they aren't that bad at all, considering the CPU is not deleted. So 63, 65, 65, 57. If Cinebench R15 passes easily and you don't want to push higher, then you can actually start to look for like daily stability. But the main difference between like a real stress program like Pra95 or similar compared to Cinebench is that Cinebench does not utilize the so-called AVX instruction sets, and the original mainstream Sandy Bridge and Ivy Bridge CPUs, they do feature the standard AVX1 instruction sets, so just the AVX1. AVX based workloads will have like 10 degrees higher CPU temperatures. So if I'm running like around 60, 63 degrees on the CPU at the moment, I would expect that the temperatures in Pra95 will be like 73 or so. So you do want to have some headroom left. So if you are already running very high temperatures in Cinebench, it's very risky to run something like Pra95. There's a real risk that the CPU will hit the thermal max temperature, so just saying. So we scored 834 points in Cinebench. We can close that right now. And we can open Pra95. This is the latest version pretty much. So we cannot disable AVX and we don't want to. So what I like to do is I like to run small FFT, maximum heat, FPU stress, and so on. RAM not tested that much. And OK. See, temperatures went straight up to like 73, so 10 degrees warmer than in Cinebench. So now we have to just check what's the clock time. So 2017. I would recommend you let this to run. If you want to test this as your like daily overclock, you want to run this for at least like an hour or two. Maybe longer time period is preferred. Some people like to run this test like for overnight, but I don't think it's really required. Like a few hours is definitely enough. I usually run like 2 to 3 hours or so. So 71, 78, 77, 69. So much warmer than in Cinebench. This does not stress the memory, as we already read, but if you just run like XMP level settings, you should be pretty much stable, because those are the stock values of the memory kit you have installed. But you can obviously stress test the memories as well if you have any doubt that they are unstable. But yeah, so if we started at 2017, you would like to run this for a few hours. So if it's still stable after like 2 to 4 hours, then you can pretty much call it a stable overclock. Then you can do like your normal daily stuff, like video rendering, web browsing, gaming, and if it's still stable, then hey, it does work. So it's actually stable. So we can actually close that one right now. These are actually quite good temperatures, considering that the CPU is not deleted and at 1.25 volts. Now, if you are interested on how well the CPU actually did, I have 2 screenshots over here. So this CPU was able to do 4.7 GHz overclock at 1.26 volts, so 200 MHz higher than what we are running at the moment, and 4.8 at around like 1.325 to 1.33 volts. And even at this voltage, the Cinebench temperatures weren't that bad really, 70, 75, 73, 65. But this would be like the ultimate max of this CPU, at least without deleting. So 4.9 wouldn't do even if I set Vico over 1.4 volts. So that's pretty much it. If you want to test, if you want to double check the memory settings, like if you have some doubt that the memory is not stable, you can run something like HEI memtest. So I recommend you just open Task Manager and the Performance tab to see the overall memory size or capacity that's being used at the moment and how much there's left. I am not running the paid version of HEI memtest, so we cannot stress the entire capacity in a single execution. So I just have to open one execution right now, and I will set 3000, start testing. And now the memory use went up from 1 GB up to 4 GB. And then we will open another execution of memtest, and we will set 3000 once again. Now we are running 7 GB out of 7.9, or around 8. And now I want to have some headroom left, so I will just set 800 MHz or 800 MB over here. So now we are pretty much running around the maximum capacity of the memory. So 7.7 out of 7.9 GB being used at the moment, 97%. So you would just want to let these to run up to 100%, and if they do pass, so if every execution passes up to 100% without any errors, then that's pretty much stable. This is the best way to test the stability of your memory. You really have to test the entire capacity of the memory you have installed in your system. So if you have installed 60 GB, you have to stress test 16 GB. If you have installed 32 GB, you have to test that entire 32 gigabyte capacity of the memory you have installed. But this should be fully stable anyways, as this is just the XMP settings. But yeah, so that's how you overclock an Ivy Bridge or Sandy Bridge CPU on a Z77 motherboard in like the simple way. So if you like to see this tutorial even in 2020, then please give a thumbs up and subscribe to my channel if you wish. And other than that, thanks for watching once again, and I will see you on the next one.